That's great. I just need to share my presentation.
We see it.
Great, thank you. Good afternoon, everyone, and thank you for allowing me the time today to talk to you about two subjects. The first subject about the Rolls-Royce SMR program, and the second point is the Nuclear Advanced Manufacturing Research Centre and how they support supplier and supplier development through their Fit for Nuclear program. So myself, I'm 30 plus years working in nuclear, half of those within defence nuclear, the last half within civil nuclear, covering a wide range of nuclear supply chain projects within that time. I am now the group head of supply chain for the new Rolls-Royce SMR Limited business. So who is Rolls-Royce SMR Limited? First of all, we are not a developer. We are actually a technology vendor. So we design, manufacture, supply, commission and install the reactors on a turnkey basis. We're currently made up of three major shareholders, Rolls-Royce being the first. Our experience being is we've spent 60 years manufacturing, designing, manufacturing, supplying nuclear power plants to the UK Royal Navy for the submarine programs. Our other major shareholder is Exelon. Exelon, obviously a very well-known US operator, one of the largest fleets, or the largest fleet within the US. And the last investor is an investment company within the UK, B&F Resources, who have a significant level of investment within the energy sector within the UK. So, what is the Rolls-Royce SMR? Our approach is a completely different approach to supplying a nuclear power plant to the grid. It's a 470 megawatt reactor. The main points on this one here, it's a factory fabricated, not a site fabricated reactor. All the elements of the reactor need to be road transported, and they will be modularized to ease construction, installation, and then obviously later on as part of the ongoing maintenance and operations of the reactor. It's quite small, so it has a plant area of around about just under 50,000 square meters, approximately around about 2 international football pitches of size, comprising of both of standard sort of nuclear plant constructions. So we still have a reactor island, we still have a turbine island, a cooling water island, and fuel storage, fuel management. And then obviously we have facilities for the ongoing management of that plant. So why is this approach different? And this sort of comes to the topic with regards to how does the supply chain integrate within this reactor design. As I mentioned before, it's a completely new and different way of building nuclear reactor plants. So the first point is how do I factory supply a nuclear power plant? Well, the biggest problem that nuclear power plants have today is, depending on their location, they have different requirements, different regulatory requirements, which require a high level of design change, and then that design change having to integrate within that design, and then that creates a long-term challenge and cost to supply the reactor. So the Rolls-Royce SMR, it is built on top of an asymmetric bearing. So the whole plant sits on the bearing, and This means that a lot of the site-specific requirements can be mitigated before we start building the factory on top of the reactor. The way we approach that then is we have if you can see on the slide, we actually see from my cursor here, we actually build a factory over the top of the plant. So the reason being why we do this is to ensure there's a lot of time lost in construction. Approximately around about 60% of the time is lost due to weather conditions, adverse conditions that allow that to mean that the reactor is either unable to be built at that time or delays the program further. So we will build what we class as the fourth factory, and the fourth factory is built over the top of the reactor plant. We have other factories, so we'll have what's classed as the primary plant factory. This is the heavy facility where the reactor pressure vessel, the pressurizers, the steam generators, the large, heavy, very high quality required components will be manufactured. And then we also have civil modules, a civil module factory, and a systems module factory, or a number of system module factories. And you can see a sort of diagram of the modules. So these modules are all ISO container size to allow them to be road transported, and that's the same with regards to the civil construction. What it means by having a factory-based reactor is a lot of the qualification, a lot of the manufacture, a lot of the inspection, tests, qualification requirements are done within a factory condition, and then they are brought to site and qualified, and then they are then installed quite quickly into the site location. What this also means that from a modular perspective is that we can compact the site to quite a small size, and that is representative of the 50,000 square meter site size location. So why is this different? Obviously, we talk about, we've heard today a number of different what we class as mega projects. Hinkley Point C, the latest one in the UK. They're very they're significantly large in both size, construction, and in cost, which makes it very difficult to invest in those requirements. So the way the Rolls-Royce approach is we are designing for market. So what we are not introducing is we're not introducing any new nuclear technology. So this is a PWR, pressurized water reactor, that has been manufactured for many decades. However, we are then approaching, instead of changing the reactor design to make it into an SMR, we're changing how the SMR is manufactured, supplied, installed, and commissioned on site. What that means is we can then reduce the cost associated. We're not introducing new costs, new risks into that process. We're using technology that we have known about for, in Rolls-Royce, 60 plus years. However, we are then producing it via a factory, which means that we have a lower capital expenditure, and we've got repeatability. So we're hitting a sort of a productionized element for the reactor. As I mentioned before, we have the seismic isolation and a smaller footprint, which means we can standardize sites. So it doesn't matter whether the module is being built for a reactor in the UK or if it's being for a reactor within Poland, for example. And also I mentioned about the site certainty with the site assembly factory, which we class as the fourth factory, to improve on and provide a schedule certainty to the developers. So when we come down to what is the question with regards to supply chain, localization, opportunities for the supply chain to be engaged. As I mentioned there, we are not looking at, as I say, it's not a mega project. And as it's not a mega project, we're looking for organizations, supply chains, not just to supply to their country that they're working in. We are looking at organizations that have the ability to supply into the module factories or into the civil factories or into the heavy factories, but then they have the ability to be able to re-export those components into other countries, into other build programs that we do have. We're also looking at, if we're looking at a localized or regionalized nuclear program, and say, for example, Poland is one of those, we could then also introduce and develop the module factories or civil factories within that region, and looking at for that region, once again, not just only to supply to their nuclear build programs, but potentially to other nuclear build programs around the world. This requires a lot of support from other areas. So we're also looking to invest in research and development. We work in the UK, we work very, very closely with the universities, nuclear institutes, training centres, advanced manufacturing, and I'm going to come on to talk about the nuclear advanced manufacturing centres. And obviously we have to have a very, very close link with the regulators. So briefly touching on the Nuclear Advanced Manufacturing Research Centre. So this is an organisation that has been set up within the UK. The research centre helps UK companies win work across the whole nuclear sector. So this covers both new build programmes, operations of existing nuclear fleet, or decommissioning programmes that we have ongoing in the UK. But they also offer support into other high value manufacturing industries as well. And the facilities are open to a lot of companies that wish to support. So how does this do this? So the Nuclear Advanced Manufacturing Research Centre, it improves innovation. So it is supported by a high number of industry leaders who provide either capability, equipment, resources, intellectual property that help and develop organisations to upskill their businesses to allow them to compete effectively within the nuclear industry. So we cover it from a number of aspects. So you've got nuclear innovation. So how do I improve the techniques? How do I take time out of manufacturing components? How do I introduce new, novel techniques without the risk of trying to demonstrate that on a first time application? And how do I, whilst doing all those programs to increase the time, reduce the cost, how do I ensure the quality is maintained within those products that they're looking to supply? Supply chain, it's very, very difficult for a supplier to get involved. As we heard on previous presentations, is you have the tier one vendors. They have either a very, very horizontal supply chain or a very, very vertical supply chain. And how does a supplier that is working at the tier 3s or tier 4s, how do they get to be in a position to be able to supply to those programs? It's very, very difficult. And the Nuclear Advanced Manufacturing Research Centre provides that help and support to those suppliers. By doing so, they're looking to raise quality. How do they improve their capability? What is the requirements? What are the codes that they have to supply to? What is the documentation? What is all the questions that are posed to a supplier when they look at something of a new requirement as a nuclear plant or a nuclear component? How do they bridge the gap between what they supply today and what that would be required to support a nuclear application? So within the Nuclear Advanced Manufacturing Research Centre, they have a number of programs. So they have the Fit for Nuclear program, and then they have the Fit for Offshore Renewable programs, and also support other sectors. They, as I mentioned before, they look at demand modelling. This is the demand modelling is how many plants are being built within the UK, how many plants are going to be built within the rest of the world. Is there an opportunity for a supplier to be able to support? If so, what is the sort of the construction schedules? Because a lot of suppliers, you can't. We say feast and famine. We have a lot of work and then we have no work, and no supplier can support their programs when we hit the famine and waiting for the next project to come along. So how does Fit for Nuclear work? What it does is it's a So it's a two-stage approach. So the first stage is there's a free online assessment that any organisation can access, and if there's a certain if they meet certain criteria and they've got the opportunity to be able to support the Fit for Nuclear programme, then the Nuclear Advanced Manufacturing Research Centre then visits the supplier. They provide expertise into their organisation. They help to identify areas that can be developed. Then from that point onwards, they create an action plan, and then they provide an ongoing support through that programme. Also to mention here, this is not just about nuclear. The Fit for Nuclear programme, whilst it covers nuclear, predominantly nuclear components or nuclear companies looking to supply that, the Fit for Nuclear programme also provides other expertise and support in other areas of the business, because those areas are, as mentioned in the previous presentation, there's things like, you've got codes and standards requirements. You've also got nuclear safety culture, the IAEA GSR 2 requirements, and then you've got all different ISO standards. All those things have to come together, and the assessment team look at both how they manage their business from a strategy point of view, how can they support in design and project management, how do they develop their people, how do they maintain their people, how do they train, how do they develop a nuclear safety culture, how do they deliver quality, maintain quality throughout that programme. What it does from a Fit for Nuclear programme, so within the UK, that has generated over 1.4 billion of new business by companies that have been working on the Fit for Nuclear programme, which is a great success for the Nuclear Advanced Manufacturing Research Centre. So that was quite a quick run through of the Rolls-Royce SMR programme and also the NMRC, and happy to take any questions.
Thank you, Richard, for these two presentations. Obviously, there are questions to both. So maybe I start with your last presentation about NMRC. My question is Fit for Nuclear. What is the cost of this program? Because it's probably costly one, and who finance it? Who had financed it?
The cost is, it's a mixture. So in the UK, the investment programme, it is what we class as match funded. So the cost, half the cost comes from the UK grant requirements, and then the other half is invested by the organisation that is looking to use the facilities and the programme. So it's a 50-50 match funded.
In terms of numbers, you know the overall cost in terms of how many euros, how many pounds?
I don't. I'm afraid. I don't.
Okay.
What I will say, it all depends on the supplier. Mm-hmm. So you've got an organisation who is supplying already into the nuclear industry within the UK, or supplying to another nuclear industry. It's more of an adaptation. But then you also have organisations who have a product that they want to bring that product into a nuclear industry. Now that requires more investment and more requirement and more time to do it. So it scales depending on your entry level into nuclear.
Okay. Obviously, such organization as NMRC would be very required in Poland, providing we'll develop the project. And you know how old is this company when it was established?
Yes, so the nuclear in the wider Rolls-Royce, we have advanced manufacturing research centres for industry, aerospace industry. So we have had those for probably, I'd say probably about 15 years. With the Nuclear Advanced Manufacturing Research Centre, that went live, I believe, around about 2013, 2014, in preparation for Hinkley Point C. This was all about how does the UK government and industry get to be in a position that they wanted localisation. We wanted to increase the value of what we could supply to Hinkley Point C, and this was the mechanism that was introduced.
Okay, thank you very much for this part. And Now, questions referring to your first presentation concerning SMRs. As you probably well know, SMR is hot issue also in Poland. And my question refers to the issue of competition between these two technologies. In your opinion, SMR is a potential competitor to nuclear power plant, or both technologies are complementary?
We believe you need both. You know, these are complementary. There are different applications. Obviously, a large, what we class as a mega project, a large reactor plant needs access to, you know, significant water cooling requirements, whereas an SMR has less of a demand on the resources. So you can locate an SMR in a different region or an area that is not close to a shoreline. So we do believe that they are complementary in their applications.
In terms of cost, because you haven't mentioned that what is the let's say expected cost of such technology in terms per megawatt, and obviously in comparison with regular nuclear power plant?
Yeah, so we currently estimate, using the different approach to the supply and manufacture and install of the SMR, that our localized cost of electricity is in the region of around about £50 per megawatt, €50 per megawatt hour. Obviously, in the UK, I think that is around about the 100 for Hinkley Point C is approximately around about €100 per megawatt hour, or it's about £92 per megawatt hour.
And the last questions concerning that, there are many companies which also develop SMRs. Which company, in your opinion, could be the first in terms of implementation of project, of real project? Of course, it would be Royce, I guess. Yes, your answer.
I have to well, I have to say Rolls-Royce. I mean, the only reason why I do say Rolls-Royce is because, you know, we're not introducing something different. You know, what we're introducing here is a process, is an application, is how to bring it to site. As we've seen with a lot of other projects, with new technology creates different problems. With mega projects creates other challenges. The Rolls-Royce SMR, whilst we're not just starting today. You know, I know the company has only been announced probably in the last week. You know, COP26, but the program's been ongoing now for around about 5 years. So we're 5 years developing the SMR design in parallel. So.
And the last question, in Poland, as you know, we'll gradually phase out coal power plants. And a lot of experts believe that the SMRs could be applied to these sites where coal-fired power plants will be shuttled down. And on the other hand, there are some experts who are saying that SMRs are not good for, let's say, system power plants, but mostly for industrial purposes. So what's your opinion concerning that?
Yeah, I mean, the first question is land that has been used existingly for other power generation has the infrastructure, it has the grid, it has the application to allow an SMR to be built within that area. You know, that improves or reduces the level of investment required to develop onto the grid. So can you repeat the second part of the question? The second part was.
Second part referred to whether SMRs are good for energy sector, but not only for industrial ones.
Yes. So, you know, the SMR design has many applications. You know, at the end of the day, it is a 430 megawatt reactor. It's not an AP1000 from size or an EPR from a power output. one of the things that we're designing in as part of this process is you don't have to have one SMR. You can have a fleet of SMRs, and the fleet of SMRs can have a multitude of applications. So we are talking about hybrid fuels for space hydrogen production, energy for very high energy applications, for example, data centers. So we can use both an SMR to support a local industrial requirement in the area, or you can have a number of SMRs to put in a power load to support sort of more of a power generation application.
And the last question, as you probably heard, some Polish companies have signed MOUs of letter of intent with some developers of this technology, US developers. And my question refers to your position. Have you contacted any Polish entity in terms of this transfer of this technology or sale of such products in Poland?
Yes, we've started the process of identifying organisations to support the programme. We haven't signed any MOUs as yet, but we haven't signed any MOUs with any organisations at this stage. What we're looking at is what we need to ensure is we're not looking for a supplier in Poland for one application. We're looking for supply sources that can support both Polish nuclear aspirations, but also other international. So we are looking at it from a different perspective. So I'm looking at organisations who has the capability, has the capacity, and the ability to productionise the components that we're talking about for a greater volume than what we're talking today. So we are in the stages now of identifying organisations within Poland and within Europe that can support those aspirations.
I see also additional questions. Since we still have 1 minute, I ask this question. Is Rolls-Royce applying modularization in construction to shorten construction time and cost?
Yes. But in addition to that, modularization allows you to, as I said, this has to be road transportable. We want to be able to put an SMR into regions and areas which, do not have access to ports and other programs. So modularization has a number of benefits. It allows us to transport by road. It also allows us to build and construct and validate within a factory environment rather than being on a site environment. And then it allows us the speed to be able to install and commission and connect those modules together. And then also one of the other major points is if you want to change out a technology, if you want to, as part of your overhaul activities of your reactor, you have the ability to take out a module and have a new module already ready, built, supplied, so that minimises the time that your plant is actually down for maintenance.
Okay. And the last question, very last question. Who will be or are the financiers of this SMR?
For the SMR program, so obviously we're in a design, we're undertaking the generic design assessment process now. If you're asking who's going to be the first person to buy a Rolls-Royce SMR,
I think the question refers who's been financing till now, and if necessary, works will be needed, who will finance them. I think it's not my question. I read it.
No, it's been financed in a number of ways. So the very, very early stages was solely funded by Rolls-Royce. What we class as phase 1 was a match funded with UK government, with Rolls-Royce, and also key industrial partners within the UK. Phase 2, once again, we have a grant from the UK government, approximately around about £210 million, and the remainder has been funded up to around about £500 million, funded by Rolls-Royce, Exelon, and B&F, our shareholders.
Okay, thank you very much for your answers. Thank you for your time, for your presentation, Richard, and hope to see you soon, let's say, with your product.
Thank you very much.
Thank you.